let's switch gears and talk about another type of chemistry. And to be honest, all through Gen Chem 1 and 2, we haven't really gotten to this point where we can talk about nuclear chemistry and understand what's really going on. So the words nuclear chemistry have a certain connotation to them. It could elicit good things, it could elicit bad things. So what are some of the words that that we can think of when we talk about nuclear chemistry? For instance, we have power plants. So we have nuclear power plants. Okay. Where I'm located in Toledo, we have 2 power plants very close by. We have the Fermi complex near Detroit. We also have the Davis-Besse nuclear power plant near Port Clinton. So nuclear power is one of those is a big deal. We also have nuclear bombs or nuclear weapons. Starting with the first atomic bombs that were dropped in Japan at the end of World War II, up until the weapons that are trying to be banned by every government in the world. Another thing that goes along with power plants and nuclear weapons, nuclear waste. And that's one of the big problems with dealing with nuclear chemistry. After you complete the reaction, where do you put all the excess reagents? Where do you put all the waste? Okay. Another thing that could come up when we talk about nuclear chemistry, nuclear medicine. Where we can use nucleides to help us see inside the body without even opening up our bodies, without even making an incision. We can also use nuclear medicine to help cure some of our diseases. Okay, so just to remember that there are 2 fundamental particles that make up the nucleus. We have the proton, which has a positive charge, and we have the neutron, which is a negative charge. Now, every time we talked about chemical reaction, so far in Gen Chem 1 and Gen Chem 2, we've been concerned primarily with the electrons, because the electrons are the species that really drive a normal chemical reaction. Well, for nuclear chemistry, we've got to take a little bit of a different turn, and we're going to focus primarily on the subatomic particles inside the atom, the proton and the neutron. Okay, so before we really take a look at what a nuclear reaction looks like, let's see how nuclear reactions compare to ordinary reactions. So looking at plain reactions, for an ordinary reaction, atoms are going to be rearranged by the breaking and forming of bonds. Okay, for a nuclear reaction, it's the elements, or more specifically, isotopes, are converted from one to another. Okay, now looking at the types of particles involved in reactions, if we're looking at an ordinary reaction, electrons are the key. Electrons are the only particles involved. For a nuclear reaction, we're going to use protons, neutrons, electrons, and others. Now, what about the energy? For an ordinary reaction, ordinary chemical reaction, energy is absorbed or released. And usually we're dealing with small amounts. And I'm just going to put small amounts in quotation marks, because usually we're not dealing with anything really major. usually our chemical reactions, the energies that we're dealing with, are usually within 1,000 kilojoules or less. We're not doing any. The reactions that we've looked at so far haven't generated a whole lot of energy out, beyond 1,000 kilojoules. For a nuclear reaction, same thing. So energy is absorbed or released. So let me change energy to thing. So same thing here, but we're talking about huge amounts of energy. So we're talking about megajoules, or maybe you may hear of energy being talked about in terms of megatons. So while we're still talking about energy being absorbed or released, now when we're quantifying that energy, we're talking about millions of joules, or we're talking about megatons. Okay, what about rates of reactions? For an ordinary reaction, temperature, pressure, concentration, and catalysts all influence the rate of a reaction. Okay. For a nuclear reaction, not affected. So what I'm going to say is this. For a normal chemical reaction, and we talked about this back in chapter 14 when we were studying kinetics, we could influence the rate of a reaction. We could make a reaction go faster or slower if we played around with the temperature, the pressure, the concentrations of the species, and if we add a catalyst to the mix. We could make the reaction go faster or slower. What I'm saying now for a nuclear reaction, it doesn't matter what we do. If we change the temperature, pressure, the concentration, or we add a catalyst, it will have no effect on the rate of a nuclear reaction.